Hello, can you guys hear me? Good. So I'm Sreeram. I run a small software company called Clay Labs. We are just 6 people. We do a lot of compiler work and a bit of machine learning and non-machine learning AI stuff. It's a lot of fun and a lot of stress, goes without saying. First, I'm not a fan of pair programming. You want to take a break, you're stuck. You're not in the mood, you're tired, you're stuck. But pair programming with a computer, that sounds interesting if it is possible. Well, I don't know if it's possible. I mean, in the general case. So, what do I mean by this? Can we get the computer to write code for us? Yes or no? We do it all the time. Two very common examples are compilers and machine learning. So, how many of you are familiar with compilers? Machine learning. So, if you take a neural network that can recognize, say, cats and differentiate between cats and dogs, the neural network is a function that takes the pixels, applies linear combinations and a thresholding function, and then does that again and again for many, many layers. It's just a function. The thing is, it's not possible for us to write the function. So we use a training algorithm and give the computer a lot of examples, and the computer writes the function for us. So another example is compilers. Compilers take a high-level language, a specification, and produce low-level code. They write the low-level code. So computers do write code for us all the time, and we use both of these technologies like day in, day out. But that does not count as pair programming. We want pair programming to be something more, right? What are the problems with compilers and machine learning? The generated code is almost impossible to understand. Very few of us are experts in machine code, and scientists are struggling to understand what neural networks are doing. And every little bit of visualization that they do is seen as a breakthrough, right? So the question is it possible for the computer to write understandable code? And not just understandable code, but interact with this, collaborate with this during the process of writing code. So I'm going to, the answer is, can we get this? Unfortunately, the answer is no, right? But in limited, narrow domains, yes, it's possible. And, in my lifetime, I hope to see this. Maybe more than that, we'll see. So, as a, what do I mean by these limited, narrow cases? I'm going to take a very small, simple, fun toy that me and my colleagues built some time back, and I want to show that to you. So, me and my computer are going to write some code now, and the kind of code that we can write together right now with this particular system are what are called morphological functions in language, like structural transformations. So if you take English, for example, plural to singular is a structural transformation. You remove some characters, add some characters, append some characters. Past tense to present tense is a structural transformation, whereas opposites are not structural transformations, right? Big and small, there is no commonality between the words. It's meaning-based. Structural transformations are not meaning-based, right? So you can convert tense. You can do a whole bunch of things. There are all kinds of grammatical forms, say root word finding. So one example I'm going to take today is converting a plural word to singular form. Okay? If we were to write such a function by us, of course, there are tons of third-party libraries out there, and I come to what are the shortcomings with them. I mean, once you've got a fully functioning, mature library, maybe not bad, but still there are some shortcomings, and it's a hellish process to write it. The people who made it, they've gone through a lot of pain. So, just imagine that we were writing this by ourselves. How would you go about writing a function that takes an English plural word, assumes that it's in plural form, and returns the singular version of it? Anybody? Dictionary. So, there are many cases where people use, so I was just asking my neighbor there, hey, can you give me some plural words, right? He came up with words that, so for example, if you take Harry Potter, muggles is a plural word. We want our system to work for that also, right? And so dictionary is not a great solution, right? It's a kind of a very blunt and doesn't generalize well. The simplest way to write it is with if statements, right? So let me show you. Just give me a moment. No, no, no. So many of these plural to singular and these morphological operations are operations where, hey, replace this with this, add this, remove this. Replace this with this, add this and remove this can all be thought of as a splice operation. Okay? Which I will show you. All right. Nope, nope, nope. It's all good. So we want to transform the string, make some structural modification to it. Because we are not, this function is not going to be bulletproof. It can make mistakes. And when it does make mistakes, we want it to support giving alternatives. It might give 0 or it might give multiple. It's ambiguous, right? So that's why we return an array of strings. So this Swift function we want to write. How do we go about writing it? Okay. So bottles. was typing in the wrong file. So I just give it an example. Okay? So here is an example. Bottles, the plural form. The singular form is bottle. And the computer is writing the code for me. Swift code. So what is it doing? It's trying to figure out a pattern by which I can transform the left to the right. And that pattern should be as you should be reading and transforming as few of the characters as possible. Therefore, it generalizes. Okay, so it will apply to other cases also. If I say, okay, if equal to bottles, then return bottle, then it won't work for any other words. But if I just check, is the word ending with S, then remove the S. The only thing I'm looking at is the S at the end. And then it gets removed. So that's what this does. It looks for match from the behind, look for offset 0, look for S. Then we replace one character from the back with the empty string. So replacing S with the empty string gives us bottle. So why is this? Getting confused with this. Okay. Just give me a moment. Yes. Sublime text was not loading the answer. Okay. If I save it, yes, gives me the answer. Tables, gives me same function is running. So give me some plural words, and we'll see the computer chairs. It works. Huh? Geese. Obviously, it doesn't know. Okay. So what we do is ponies. Ponies. Okay. So let's say, so the thing is, in this pair programming environment, the computer is writing the code. Match ponies, match bottles. Okay. And it's getting that from the examples. Okay. So if I give geese, it's goose, right? So I have to put it there. Geese, goose. Okay. So give me something like geese. Teeth. Tooth. So now similarly, I spent some time whenever I was, it's a very relaxing way by which you and the computer can work together and write some if statements, right? So let's see what it does. You say shoop. Sorry, I don't know the answer. So I spend a bunch of time. So now I've added some 50 odd examples that I entered. Okay. Now let's see. So here's what I'll tell you. Any plural that you give me, it has to be a valid plural word in English. Okay. Muggles maybe work. I am not tried it actually. And it will give you the singular. And if it doesn't, I can fix it instantly. So that's something very interesting, because if you're familiar with machine learning, in machine learning, when something breaks, you can't just add that one example to the training data and expect it to work. Because, in fact, the machine learning system will not work for all training data. Right? So, that's what we've got now. Who's up for it? Children. Child. Huh? People. Sorry, I don't know the answer. I'll fix it immediately. People, person. Yes. Next. Huh? M-double-E? What is that? Meats. Okay. Moots. I didn't know meats was a word. Let's. Scissors. What is the spelling of scissors? S-E-I? Yes. What is it? Oh, of course, it's a pair of scissors. Pants. Ah. Fish. Next, come on. Furniture. Give me some simple cases, people. Furniture. Then. For syllables. Alumni. Alumnus. Schools. News. Hold on. Let's get some more. The point is, unlike machine learning systems, this can be fixed instantly. Formulae. Yes. Next. Data. Next, come on. Feedback. Oh, this unchanging plurals, please. I don't know many of them, so I didn't give it much of it. Let me give it now. Feedback. Foodback. Huh? Radii. Yes. Next. Huh? Sheep. That actually I gave it an example. Then, sons in, no, it's got to be one word, no compound word. Sons. iPhones. Ambiguous. Okay, let's collect all the cases where we got it wrong. Meats. What is it? Leaves. Leaf. I don't remember. There are 50 examples. Men. More, come on. Food, I don't know. Sorry, I don't know. I just remember trying it earlier and said, don't know. Any more examples? Algae. Spelling? Is that right? What's the right answer? Same, is it? Okay. Next. I'll go with photos. DI. Douse. You guys are smart. So the point is, the examples is taken and it's given code that is understandable. You can go through the debugger. If something fails, you can actually go through the debugger and figure out where it's missing. And in fact, I can make the system add more comments where it can it'll be easier to debug, right? So now let's fix some of them. Okay, meats. Then what else? Let's collect fish. Furniture. It's easier to type than to copy paste. Syllables. What is it? That's correct. News. Then food. Dice. What's the right answer? Die. Okay, let's take some of this. Was that? Oh, sorry. Meat. Is that a word? Meats? Ah, okay. All right. Oh yeah, that's right. Dice. So, let's look at some of this. So, for example, so this rule matches all of these things: ponies, companies, babies, cities, copies. Okay, but what does it do? This match list is from the examples, but what it does is it just looks at the IES. Okay, and then it has to not match with all the other words in the examples which have IES. It tries to find the minimal set of conditions that, there's a typo there, minimal set of conditions which will prevent the spurious words from coming in. And once that happens, the last three letters are replaced with Y. So it touches and modifies the minimal number of letters and does the fewest number of checks. And by virtue of that, it generalizes pretty well. Okay? If you play this game a little while, you can be like really, really good. So, wouldn't that be nice if we had a more collaborative environment where the computer writes code for us for all kinds of things? And I think it's possible. And systems like that have to be built. It's a combination of machine learning and compiler kind of thinking, but you've got the difference between, the problem with both of these fields is that they are used to writing code that is not meant for human consumption. So how can we take existing techniques and massage them so that the computer can write human understandable code? That, can we do this for user interface development? Can we do this for image recognition, right? If you take something like the state-of-the-art neural network systems, there are adversarial techniques by which a single invisible pixel, if you change, it gets a completely wrong classification. So if you take one of the recent image recognition systems and show it gorilla. Okay, it says gorilla. But then a hacker can take this image, make some small imperceptible changes, and then all of a sudden it'll say dolphin. Or something else totally different. It might say fan on the ceiling, right? And imagine if, see, the software that we write are pretty buggy, but it's not so ridiculous. And one of the reasons is because the programs written by the neural network learning algorithms, the deep learning algorithms, are impenetrable to human beings. And it's not just about can we understand. We should be able to contribute at a higher level, right? I should be able to analyze it. So what I'm saying is, this is an interesting point of view, right? Neural networks and compiler output are sort of like machine code, right? Can you write your iOS app in machine code? Yes, you can, but nobody does it. And if somebody gave you a binary, you can't understand it. It's very, very difficult, right? That's what the computer does to us. Compilers and machine learning systems give us like binaries, machine code. Even the neural network is sort of like machine code, just numbers. You can't make sense of it. Whereas, if you give me a Swift program, I can run the Swift static analyzer on it, I can run the type checker on it, I can run the syntax coloring system on it, I can use Xcode refactoring tools and take the program and then make changes without changing the behavior. I can do so much more with the Swift program than I can do with the machine code program. So if we try to make computers write human understandable code, could be interesting. And could be applied to many other fields where you need reliability and easy, quick fixes. So that's all. Thank you, guys. Thank you.